Already yesterday, late afternoon, John presented about generic programming. Now we are going into the new features of the new standard, which is concept, and we are still talking about concept. We will see, again, almost the same things, but we are going to look at concept, how they can improve the situation. Just a quick overview. Why do we need generic programming? C++ is strongly typed, okay? It's a nice thing, it's not a bad thing. I don't know how many of you are used to write Python code. It's nice, but for production, it's not the best thing, in my opinion, because you might realize problems at runtime, and it's better to realize as soon as possible. So there are different philosophies in Python, but in C++ it's better safe than sorry. Okay, actually it is better type safe. This is a citation from I don't know where, but it was nice because strong typing is actually a very good thing to have. So with strong typing, it means that when we have something, we know exactly that the type of this thing, and it is not going to change. But this also means that if we want to write an algorithm, if we cannot generalize it, we are going to write the same function again and again and again for every single type or combination of types. So that's why we need it. And in C++, generic programming is templates. This helps us because we can actually generalize code, but we are removing almost all the constraints. So it actually, in that case, we are just saying, okay, I have a placeholder type T, and whatever we want, we can put it there. It's not perfectly true, because it might complain about a function is this plus function is not available for the type that you used. Again, a compile time, but from some, let's say, it could be a good point of view saying that template are, let's say, duck typing at compile time. We saw Sphinai this morning, if I recall correctly from John. It actually enables us to constrain things, not just whatever you want, you can pass it. We can constrain things by saying, no, this should be, for example, this should be to integral. Oh, well, that's a typo, because it should be integral or floating point. But the idea is that you can actually constrain the types that you have in templates. Sphinai, as we saw, is supported by standard library. We have the enable if that allows us to express different conditions. And there are, let's say, a lot of common and useful requirements that we can already reuse from the standard library, like the is integral or is floating point. They are available in the type traits include. It's super nice that we can figure out at compile time the errors. Less error in production, perfect. But in this very trivial snippet, there is an error. I'm not going to ask you what is the error. It might be trivial to find out if you already know the error. But the point is, this is what the output of GCC for this single error is. And Clang is even worse, because it reports 200 lines. It is just one of the 9 errors that it reports. Actually, the problem is just that I have a vector of int, and I can sort it with the sort algorithm available in the standard library. Then I create a vector of number, which is this class, which is simply an int, a long, but it's an integer. And I use the same thing, but this struct doesn't implement the comparison operator. And it turns out to be like this, the error. And you can go on and reading, and you might find out what the problem is. There, it is visible that it cannot compare the thing. OK, but you have to find the right error inside this long output. So Sphinx is a very powerful tool, but it has some downsides, like the errors. And I don't know how much is true, but Sphinx, it looks like it happened in C++ more than it was looked for, because it doesn't really look, let's say, nice to see in the code a lot of Sphinx, but it is nice because you can do a lot of nice things. And different techniques and language evolution overcome some of these limitations. And one of them, the last one, is concept that has been introduced in C++ 20. This is more or less, since I never used concept, it is something very new, and I didn't have the chance yet to experiment a lot with the code with concept. These are my opinion at the moment. I don't see nothing breaking in terms of functionalities that I can implement, but it is a way more readable and terse way to write code, write the same thing that I was used to write Sphinx in. Now I can write with concept in a more easy way. And the error messages, we will see how they are improved. The entire concept feature in the C++ 20 relies on two new keywords that we are going to see, requires and concept. So we can see concept as a refinement of templates. So let's start from what we had with templates. We said, well, let's look at the snippet. We have a min function that accepts a template parameter float. Remember that you can use whatever name you prefer for the type templates. It should be, let's say, it should say something about what it is going to be. So it accepts two floats, it returns a float, and actually it works when you use it with two doubles and return a float, two doubles and return a double. Well, actually it will work with any type, because any numeric type, because I can also use ints, but I can also use chars, because they are basically convertible to ints. Because the template doesn't constrain anything. It's just a placeholder. If it is going to compile and it builds, it makes it works. Okay? It doesn't mean it makes sense for what you were supposed to do, but yeah, it doesn't work with, if I call min of two vectors, it doesn't mean anything, because the error would say, in its own way, that plus is not implemented and division is not implemented for vectors. And it's still a compile time. But the problem is that we didn't constrain the template type. So we improved the situation with Sphinx. We can say actually that the type float in the template is a floating point. We now have constrained it. And the previous two examples with integers and chars do not work anymore. The error message, as we saw with Sphinx, is a bit cryptic. It's not so straightforward to realize what's the problem, even with simple code. And so let's introduce concept. Compared to the previous version with Sphinx, it looks more or less similar. We had, look at the template type. Before we had the template type, the placeholder float, and enable ifs, checking for the requirement, for the constraint. Now we are specifying before the placeholder float, we say like a property of this thing. Now we say it should be a floating point. And actually, if you look at this last example, where I pass two integers, the error now is quite straightforward. It says, is floating point with int evaluated to false? Okay, I understand what I messed up. So we expressed the same thing. We got a better error message for the wrong case, for the bugs. And we improved also the code readability. Actually, standard floating point float replaces class float, class equals, standard enable if, standard is floating point. I mean, I don't know if you agree, but it's a nice improvement from the readability point of view. Yeah, just one point about this. We saw that it is nicer, is more terse, this new syntax. And the only difference is for Sphinx, we use things in the standard library that comes from type traits, mainly. And the names are is floating point, is integral, is whatever. And the counterparting concepts is available they include from later concepts. And it is slightly different, but very similar. It is not anymore is something. It is more like floating point, this placeholder. We already saw this new syntax. Actually, we can play a bit with it. We can use, instead of declaring the template standard floating point float, we can actually use auto. We are saying standard floating point auto, so auto, the type that will be deduced, has to be a standard floating point. It's difficult, it's a difficult question, but do you think they express exactly the same thing? Look at them, and the hint is how many placeholders, how many type template name do you see in the first version and in the second version? I mean, in the first one there is float. We define just float. While in the second one, how many placeholder? 3, because each auto is independent from the other one, right? And so they can potentially be deduced differently. So look at the last one, res03. I'm passing, what are the types I'm passing there? For the very last call there. The arguments are, one is a float and a double. And it's complaining, okay, because it doesn't know if it should be a float or a double, because it has the same name. It's a single placeholder. Okay, it's not going to implicitly convert it. It say, okay, I wanted to deduce one single type, and they are different. If you look at the previous line, result 02, we actually specified that it should be deduced to float. And so it says, okay, I'm going to use float as the float placeholder. Is it a floating point? Yes, it respects the constraints. Okay, I'm going to replace float with the capital F with the actual type float. And I can pass a float and a double. Yes, because they can implicitly be converted to a float. While with multiple placeholder, they can be deduced differently. Okay, the example that we had with the floating point auto in the arguments is exactly as having multiple template parameters because they are independent one from each other. And so it's different having the single template or using auto for each parameter, because we are using multiple placeholders. Actually, there is also another problem. In this version, I fixed the return type to float in the function min. That's let's say, a decision I took, but it is different than before. If we are going to add another placeholder also for the return type, differently from the arguments, the placeholder for the arguments that can be deduced, the type of the return type cannot be deduced. So we have to manually specify at each call that we are going to get this output, okay? With floating point, with concept is better because, for example, in this second snippet, I constrain the return type to be an integral. So it's going to realize if the type that is returned from this function is an actual integral. And it's not going to work because A has been defined as a floating point, float, double, okay, whatever it complies with a floating point concept. And we are returning a floating point thing, which is not integral. And so we get the error. Return type does not satisfy placeholder constraints. Do you see how it helps in defining what the function is expected to do? Yeah.
I have a question about that second box, standard integral auto.
Yeah.
Yeah, to me it's a bit strange that we have auto as well.
Yeah, because the concept is not a type, is a property of a type. You have also always to specify to what it applies to. The concept applies to a placeholder that can be a template parameter, or you can say, well, I don't want to specify template class with the name of the placeholder. It's enough saying auto. So integral applies to auto. Like standard floating point applies to auto. It's like saying, okay, this auto here is going to respect this concept. You can see, and we will see later an example where this model helps. You can think of the type now as both the placeholder with its concept. That's the type. Okay? It's not a real type. It's a constraint type. It could be whatever it complies with. I don't know if you like concept. I like them. And I don't know if you realize that we already use concept. We said that there are new keywords in the language, but we didn't use any new keyword. We used a new syntax because we can apply a concept to a type, which was not possible before, but we didn't use any new keyword at the moment. You didn't see any require or any concept keyword. We saw it in action in a return type of a function, like in the previous slides, integral auto. We saw it in action also as constraints over the types of the arguments of the function. Do you think that how you define the arguments of a function are so different syntactically from how you define a normal variable in your code? They are pretty much the same. Actually, you can define variables using concept. You can say, I want a res variable, which should be const, and this type that I don't want to type, like you saw, okay, I want a const auto res, but I want this auto to be constrained to be an integral. And if min returns a float, this is not going to build. This is a compile time error if min returns a float. Because float is not respecting integral auto. Do you like concept at this point? I'm selling it nicely or? Okay, so new keywords exist. So let's see how they are. Okay, now you have to follow because it's the same keyword has been used in two different locations. And the difference is, this is called clause, keep it in mind. It's a require clause, okay? And the first snippet is how we already saw how to use concept, and we didn't use any new keyword. Actually, we can say the same thing, saying, okay, create a class T placeholder, a template placeholder, T, and this thing should follow this constraint, is floating point T, okay? So I'm, let's say, separating the definition of the placeholder with the constraint to the placeholder. This standard is floating can be a Boolean expression. I can have or, ands, whatever, with different concept. Okay, it can be a long expression. In this case, a single requirement. I don't know why, but they decided that you can put require clause after the template definition or after the signal, let's say, before the body of the function. I don't know why, but they opted for this solution. There's no different in this free code. You can do whatever you prefer. Maybe choose one and don't spread differences in all your code base. And then there is the requires expression, same keyword. Okay. The previous one was checking a Boolean expression, like, is it correct, this thing that I wrote there? Like, is floating point T is respected? Does it return true? And so requires acted like an if, like, this template is valid if this condition is correct. Now it is another thing. Now it is a requires expression, and it looks similar to a function, because we can have a parameter list. It's optional. We can even skip it. Then we have a body with a lot of requirements, okay? And this full thing is going to be evaluated to a bool value. Is it true or is it false? And each requirement is like an end between each line. It should be valid this. Every requirement I write there, it should be verified for that specific, let's say, placeholder. What the requirement can be? We have 4 types of requirements. You don't have to, you don't have to learn all the things. This is presented just structured, like you understand why they decided to do these things. But when you code, generally, you don't have to think about all these things. Oh, it should be a nested thing, or you will get used to them without actually knowing everything of concept. But there are mainly 4 types of requirement that you can write in a requires expression. A simple one that answers to the question, does it build? So A plus B, that expression, does it build? If it doesn't build, it's like Sphinae. It is not an error, it's a false, okay? And that required expression would evaluate to false. There is the type requirement, and it says, this expression, is it a real type? So type name A with B. Does it build to a type? Is it a real type or not? Then you have a compound requirement. It is, does it build and returns a type? So X plus B, you can also pass no except, but let's skip it for the moment. x plus b, does it build? And if it builds, does it return something that is a t? Okay, t is a placeholder given for this requires expression in this scope. And then you can have nested requirements. It looks silly, but you can have inside the expression another requires saying, okay, this thing is evaluated to true. That's useful because this might, if I remove the requires, it becomes similar to a type requirement, and it would mean, does this thing without require builds? Instead, with the requires, we are asking, it builds, and is it evaluated to true? Is it true, this thing that I wrote there? Can you spot the difference? It's a bit, let's say, a detail, but it's important because it can be very useful, because otherwise we couldn't evaluate a template expression like that, the value of the template expression. In case I will have a slide later, I can show you an example. So we have the requires clause, which acts like an if. Let's check an expression. We have the requires expression, which is an expression and returns a Boolean value. I can combine them. So yes, it works. It works. You can have requires, and the list of requirements. This thing works, okay? Do you think it is a good idea? I don't think so. It's a no. It's written there, it's no, it's not a good idea. The guideline is generally, it's a code smell. So if you're doing that thing, probably you should think about what you're doing. Probably you want to define something else. You want to define the concept in a different way and use just the require clause with the new concept. But at the moment, we don't know how to define new concept. We know that we can reuse what the standard library provides us. But yes, we can. And that's the second keyword. With the keyword concept, we can define new concepts. We can have a bool expression there. The bool expression can be whatever it returns a Boolean value. It can be something from the type traits, like an old sphinx thing, or it can be a concept like floating point, so without the is at the beginning. It can be a requires expression. Can you tell what this num concept does? Someone that has an idea? What the concept num requires? How many requirements? That's easy. 4 requirements. Let's take the first one, because they are very similar. What the first requirement requires? Yeah, it's A plus B should build. It should compile without any error. And A plus B should, the expression should be, in the end, a t-type. Okay, and we are defining 4 constraints. So we are saying that the num concept should build should have the plus operator, the minus operator, the multiplication operator. And the last one, what do you think it is? Exactly, it's just an unary operator. Yeah, unary operator, and it's the negate function. Okay. We are not saying anything about semantic. It can be that the A plus B does whatever it does. We are just asking that it builds. We don't know what it is going to implement, that function. We said that standard concept library is there for us. It implements a lot of things. Just some basic guidelines that I was able to collect from the community. The naming of a concept should be, I mean, we already saw it. It's slightly different from what we had with type traits. The idea is that concept should not be used to constrain your implementation. It's not like this function should have these requirements. It's more like in my design of the software, I have to deal with this thing, which is a concept, and it has to, it can be reused in my code base. Okay, it can be a matrix. Okay, a matrix concept saying, okay, on a matrix I can do plus, minus, whatever. Okay, but it should not be like, oh, in this function, I need this, this, and this. It's not that. It's not what concepts are for. Actually, writing a good concept using this idea is not so easy. And so let's say the suggestion is start writing a reasonable concept, even if it looks partial. You will improve it over time. If you are designing the concept in the right way, you're not messing up the code. Let's say the bad thing that can happen is that you will realize that in your code you had a bug and you didn't know because you had a new requirement and that function, oh, I forgot about this. And so you improve the code. So it's so useful for debugging. So we already saw the example. This num concept. Do you think that float respect, the float primitive type of C++, respect this num concept? You can do all those operations on floats. Double, int, long int. So if you start using this thing, even if it is partial, it doesn't have the division. You can already start saying, okay, in my function, I want a num auto. And the compiler will check that the placeholder respects these requirements. Otherwise, you get a nice error, readable error, compared to the Sphina ones. So if you start writing code and you get to big integers, you start implementing big integers. Does big integers respect the num? It's up to you. You have to make sure that in order to big integers to respect these requirements, you have to be sure that you implemented plus, minus, multiplication, and negation. We are not saying anything about semantic. Even if it doesn't anything to big integers, that's your problem. But at compile time, it works. Okay, quiz time. Do you know what does it mean CV qualified? It's const volatile. Okay, where you put the const when you define a type. Okay. Let's start from the first one. Do you think this is correct? This is the right way to do it? How many yes? 2, 3. Okay. This one? I'm just pausing a bit, just if you want to write your own answers, and we are going to quickly check them. Mauro, if you want, you. Are you ready for the answers? Can you tell why the third one is wrong? Peter, what did we say about the type? How the concept and the type, how to consider now the type with the concept?
I think after the concept, you have to have the type.
Exactly.
And there's no...
Const applies to the type, but the type now is concept auto. Yeah. It's the whole thing, the concept and the placeholder. So we cannot put const in the middle. Okay?
Yeah. Yeah, if you swap the concept and the const, it might work. Yeah, well, that's the first case.
The first thing is correct because we are applying const to the type, which is concept auto. Okay, generally the idea, at least for me, it is easier if you read from right to left. And for example, the first one is a reference of type concept auto, which is a const. The second one is a const pointer. So the const is applied to the pointer, not to the value pointed. It's the pointer itself. And it points to something that is a concept auto, and this value is const. I don't know why I wanted to do this thing, but for me it was, I didn't know where to put the const inside the concept thing, and I thought it was helpful, but do you know why this before last is not correct? What the const keyword there applies to? You remember that you have to read from right to left as a hint. So const applies to? To?
I would say you want it to be part of name. Const.
Actually, const applies to reference. And you cannot have a const reference. Reference is already a const pointer. That's the problem. It's nothing about concept there. It's just because you cannot have a const ref. You can have a const pointer, but you cannot have a const ref.
Bottom line is that you try all the possible combinations until the code compiles.
Okay, we are to the finish. A nice thing is that since it happens at compile time, you can use static assert to do unit tests for your concept. You can, as we said, we expected the int to work, the float to work, the complex to work, but the string doesn't have plus, minus. Or maybe plus, I'm not sure. No, plus yes. It doesn't have minus, the string. So this last one is not going to build. And we can have unit tests also for concepts. And just a couple of words. With templates and Spinay, we had static polymorphism, which is nice because we don't have overhead at runtime. With concept, you can still do exactly the same thing. That's the point of, in my opinion, at the moment, they don't introduce anything breaking new. But you can write it better. It's more maintainable. It's more terse, the syntax. And also type erasure, which is, let's say, something that you can play with. There is a standard invocable concept where you can check the types you pass to a function. So we quickly checked why we need generic programming. I hope it is clear to everyone why it is nice and useful. We went from template. In reality, it is from Spinay to concept because template doesn't constrain anything by itself. It's the Spinay thing that allows us to make requirements. We quickly see the syntax, the require clause, the require expression, don't do require. And in the end, this possible application of concept, but there is nothing new. It's just writing better code. I think we are doing exactly the same thing, but we can write better code. Do you have any question? Many? Nothing? I don't know. I think we can just go on, and if later later or tomorrow we are going to have this hands-on, we can eventually discuss also, take these slides and play a bit with them, with the code, the examples that were there. Depending on what you think it is worth for you, we can also split in groups. I don't know. We'll see what's best for you. That's it. Thanks.